Okie dokie, genetic engineering. I'm going to keep this very, very basic because I know a lot of people get confused. If you are more advanced in what genetic engineering is, you can look at the advanced video. Alright, I'm going to start off with a humble bacterial cell called Jim. Jim's pretty happy. Jim has got inside him two different types of DNA. He has got a plasmid and some chromosomal DNA. This word plasmid is going to be very important. Plasmid is a type of DNA that can be swapped between bacteria cells. So let's just say Jim wanted to have the same eye color as Joanne here. Then he could do that if the plasmid was inserted into him, or into her, pardon me, and she had the plasmid of Jim, the eye color would become the exact same. Alright, so plasmid, a bit of DNA that can be transferred between bacterial cells. Now, little Jim here, I want him to be able to make some insulin for me. So what I'm going to do is I'm going to get an enzyme. I'm going to get an enzyme to come in, and it's a little bit like a pair of scissors. So my scissors are going to come along, they're going to cut apart my bacterial cell, and I'm going to isolate the plasmid. So I'm going to get an enzyme to remove the plasmid from Jim. So unfortunately now Jim is sad because, well, Jim is dead. But I now have an isolated plasmid all by itself. Alright. This plasmid isn't very useful. But what I can do is go to my human cell and take, I could look at a chromosome, and if I look into the inside of that chromosome a bit more carefully, I can look at the particular part of DNA that codes for something useful. Now, what I said earlier, I'm trying to find something useful. I'm trying to find the gene that codes for insulin. So, this bit here is my gene for insulin. Right? Insulin's that drug used in blood sugar regulation. So this little gene for insulin here, that's very useful. What I'm going to do is I'm going to cut that out again. So I'm going to get the enzyme that I had earlier on, and I'm going to cut out the particular gene that I want. So again, I'm going to use an enzyme to cut out the gene. Right, so now I've got my gene. I've isolated it. I've got my little stretch of gene here. So what? Who cares? There's no point in having that by itself, because it by itself is useless. It needs something to actually decode the instructions and make it into something useful. So what I'm going to do, I'm going to get my plasmid. Plasmids are useful. That's something that can be used by an organism to decode instructions. So I'm going to get my plasmid, and whoopsie, my scissors are a little bit wonky, but that's okay. My enzyme is going to cut open my plasmid, and I'm going to use another enzyme to stick in my gene. So I'm going to stick my enzyme into that, which I end up having a plasmid that has got my special gene inserted. Alright. So, retrack. Cut open bacteria using an enzyme, remove the plasmid, cut open the gene, got the gene that I wanted for insulin, cut it open with enzymes, and then inserted it into the plasmid using another enzyme. This plasmid I can then use to give to a bacterial cell. So let's see. I insert that into one of the enzyme Jim's buddies. If I get another little enzyme, and I insert it into my bacterial cell, then I wind up with an animal, or with a bacteria, that can produce insulin. Now this is useful, because now that my little lad is producing insulin, all I have to do is chuck him into the right conditions, and he's going to start multiplying. So eventually, my little insulin-producing bacteria will multiply to make lots of insulin-producing bacteria. And if they make lots and lots of insulin, I can sell it. Oh, and people with diabetes don't die. Alright. These guys will all have the same plasmid as my good friend Jim. Right, just as a recap then. Got my bacteria. He's a happy bacteria because he's a little plasmid in there, and a plasmid is a way of bacterial cells sharing genetic information so that they can get something physical out of it. I'm going to cut open my bacteria with an enzyme. I'm going to isolate the plasmid. I'm then going to get the human gene, the bit of the human genome, the bit of the DNA that codes for insulin. I'm going to cut that gene out using an enzyme and insert it into my plasmid. So now my plasmid has got the gene for producing DNA. That's useless by itself. I need to put it back inside a bacteria, which I will do. This bacteria can now produce a little bit of insulin. If that bacteria reproduces to make lots and lots of bacteria, they can make lots and lots of insulin, and I can get rich. Oh, and also people with diabetes don't die. And that's genetic engineering. It doesn't have to be insulin. It can be taking out a resistance to a particular herbicide from a plant and putting it into a new plant, or from a bacteria into a new plant. The answer is always the same: using enzymes to cut open plasmids, using enzymes to cut open DNA, inserting the DNA into the plasmid, and inserting that plasmid into the particular organism. Voila!